Hello, everyone, and welcome to today's lightning lesson. We're going to just get started, but first I wanted to introduce John Berryman, who is so nice as to collaborate on producing this. John is principal consultant and founder of Arcturus Labs, and we've actually known each other for a long time. We worked together at GitHub. John was engineer on the GitHub Copilot team, so he knows a thing or two about agents. And in today's lightning lesson, I think the easiest way to summarize what John is going to explain is basically like these three things. One, coding agents are a lot easier to understand than you might think at first glance. Two, they're also a lot more flexible whenever you get into the internals, and you can make them do a lot of different things. And three, current UX and interface for how coding agents leaves a lot to be desired. John's going to show kind of, some visions of how coding agents in his mind, or actually agents, more general purpose, could be used in different environments. So, um, this is slated to run for about an hour. We're going to see how much we get through because John has a pretty audacious set of examples to get through, and we'll hopefully have some Q&A at the end. So at that point, when it's time for Q&A, like you can come off camera and ask questions, and we can have a hearty discussion. Without further ado, I'm going to hand it over to you, John.
All right. Well, thank you so much for giving me the platform. It's always a pleasure to speak to a new audience. And yeah, you guys are kind of my guinea pigs for this. So if we're going through the epic amount of content, and I'm going through anything too fast, then feel free to like pop into chat or even audibly. I miss talking to people and say, ask questions and stuff. I think I will actually go under an hour on this, so feel free to interrupt if I'm glossing over something that's important to you. So yeah, um, as Greg was saying, I think we have the wrong preconceptions about assistants and agents today. We from using Claude code and Codex and whatever you use for your daily grind, we've come away with a perception that these things are really, 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 really complex. And you can only build them if you have a giant company and an immense amount of time spent to work on coding agents. The other thing is that, what are they good at? I just said it. I didn't even help. I couldn't even help it. I said coding agents. Agents, we think of them as being the thing that we use to build the software at our works. And where do we interact with them? It's basically the terminal. Maybe you're using Cursor, so there's IDE plugins, but a lot of times we don't even want to see the code anymore. We're just interfacing with these agents through the terminal. I think all of these are wrong, and it took me a while to come to that conclusion. For quite a long time, yeah, I've been consulting with AI and working with AI for 4 years now, which is kind of the whole time. But as I was working with coding agents, I also thought, wow, this is pretty neat stuff. How can they make these really complicated things? Oh, I wish I could just peer into these products and see like how they work. And what I found out when I started, pulling back the layers of the onion is it's actually really simple. And and not only is it simple, once you start playing these things and seeing what other things you can do with it besides code, you recognize that they are super flexible. I started tinkering around with coding agents inside Cursor actually because I wanted to still read stuff. I was using it to help me massage the text on blog posts. I was like, oh, this works just great for this. And then it's like it slowly dawned onto me. It like kind of leaked in over the period of months at the beginning of this year. It's like, wow, you could really use these things for anything. And it's starting to permeate our society. We're starting to realize that, but you guys are probably developers, you're very technical, and you realize that still it kind of feels like these things are for code. Also, like we're gonna go way beyond the terminal. Um, there's two things that I'm going to cover at the end, and one is like taking the agent and instead putting in the terminal, embedding it into AI products. I think it is a very important building block of the future of AI products. The other thing is taking it and inverting the user experience so that mostly whenever you interact with a traditional application, you'll be working with an agent interacting with it. This, I hope you take away from this talk, the opportunity. I think, my crystal ball is as clear as anyone else's. I can't see exactly what's going to happen in the future, but I think I will be able to show you something where you can start working with these yourselves, and you can think through how people will build product in the future. Because every single one of us, if we're software engineers, we're going to be building traditional software, but it's going to have a lot of AI built into it, a lot of AI that interacts with it. So please try to take that away from this talk. We're going to skate to where the puck is going, not where it is. All right. Chapter one. I want to show it to you. I want to strip down this complex beast of a coding agent to its simplest form, and then slowly, over a series of 6 examples, build it up to something that, guess what? It's a coding agent. And so, just to reiterate, the reason that we're here is because coding agents seem so complex. They've got slash commands, they've got tons of built-in tools, all sorts of extensions, MCP servers, UI affordances. But what you'll see is the core is very simple, and all this stuff is just basically traditional software built on top of it, built around it. It's syntactic sugar around something that's not magic. All right, so we begin. In the first demo, I introduced the absolute start of it all, just a prompt and a model. We'll get our flow down here in a second, but just a model. This code right here implements the simplest possible thing. This is written in Python. I chose Python because it feels kind of like pseudocode. Hopefully it's pretty legible to you guys. But in our main function, we take a string, the user prompt. We create a client. It happens to be Anthropic. It could be any model that you want. And then we pass the user prompt as a message into the client. And we say, okay, you create your response. We add other stuff too. We say, okay, what kind of model is this? This is Claude Haiku. We're going to do it quick and easy. We can pass in some instructions and we can get the response out. It works exactly like you think. So I can say, tell me a joke. Ta-da! And that was the entire year of 2023. That's basically all we had for a year. And we made good use of this thing too. The LangChain, that the whole idea of LangChain is like, well, you can take not just one of these, but you can take a couple of them and pass, raw text on the inside and have your your system message here be instructions about how to like pick out the right pieces. And we were able to achieve bizarrely different forms of software with just this. You have just a little piece. You have a functionality that's like taking a intern and putting them in a little bitty tiny box and saying, every time you see this, do this with it and get the output. But how does this turn into a coding agent? Okay, after every slide, I do want to reiterate, this is still easy. Everything we're going to do, we're going to build up and it will still be easy. The next thing, and this is the first thing that I would actually consider being an agent because it has some form of agency, is we need to add a tool loop around it. So easiest way is to look at the code and see what it looks like. Code is a little bit longer now. We'll have to work a little bit more to parse it, but it's not so bad yet. Just like last time, the main function takes a user prompt with just a string, and it packages this up in a way that it knows it's going to pass it to the model. This is the same model message create call that we did last time. But the only thing different is last time we didn't have that big chunk there. We just passed in the message. This time we got something new. Uh, Anthropic and all the frontier models, all the models have standardized around this notion of tools. You pass in basically a simple schema for what's the name of the tool, what is the description of the tool, what what are the inputs to the tool. In this case, we just have one, and you can even describe the types and everything with it. All this information gets packaged up and shown to a model with a prompt. It ends up being exactly the code that we had in the last slide. It's just that they are repackaging this information for you and shoving it in there right next to the instructions. So when you take one user message and you call the model, you get a response, and now the response has some options. It could be just an answer, but it could see, oh, that model, that tool is something that might be useful to call. So I'll go ahead and make that call and get the response out, read it, and then I can do something with that. And so we have to introduce a loop because now, before you put in the user message and the output is the answer. Now there's two options. It can make this tool call, make it several times, and every time the model comes back and says, "I've got more work to do, I've got another tool call," then all we do is take that out, execute the tool because it's just normal code, traditional code, and stick that information back into the the set of messages. All right. So this is new. We have a set of messages. It's not just one anymore. Once we send it to the model, get the response out, then we're going to take whatever the model said, which might be a tool call, and put it into the response. And then we check it. For the response, if we see any of the blocks have tool use, and if it's referring to our tool, which we've called Search Hacker News, then we're going to run that tool. It's just a function. Actually, let's look at it. We're going to run this function. It makes a request against this URL, gets the output. We're going to take the results, dump it back into the messages, and we're just going to keep going. This is a while loop. So every time it tries to make a call, it'll keep doing that until finally there is no tool calls and we break and go back. So let's see what this would look like when we run it. Let me get my. Does Hacker News have any book recommendations about building AI assistants? So it's a lot of gibberish on the screen, but what's it doing? Let's pick it apart. It first decided to make a tool call. You can see where it's calling exactly that. You can see what it's looking for, and you can see where we've dumped in the results without any decoration. It decided that these weren't good. So the model of its own accord in the next loop said, we're going to do another set. There we go. It's still looking. It's obviously trying hard to find something. And finally, it gives up. It says, based on my search of Hacker News, I found some relevant books recommendations, but it's kind of cool. We actually have a useful assistant. This is an agent. It can choose what to do. It has agency, and it can do a kind of cool thing. It's a very, very, very narrow task. All it can do is search for Hacker News and kind of summarize stuff, but it's a start. All right, it's easy. It's still easy. All we've done is taken the model and wrap a loop around it to call tools. Still good? We get 4 more of these and then a bonus. All right. The next thing I'll show you is this idea of tool calling in a loop has become such a popular pattern that as soon as it was introduced in the middle of 2023, basically everyone adopted it immediately. So what that means for us is we get to write much less code because the assumption is already in place that there's going to be this while loop that's doing the tool calling. All the code that you saw right here, which is sort of long, and you have to like, state the function twice. There's the definition, and here's like the actual code that runs. Now check it out. At this point, you can use any library, any language you want. They all have similar affordances. I'm using Pydantic AI. It's nice and clean. And when you create a Pydantic agent, it is exactly the tool loop thing from the second example. You say, here's the model I want. You can name it, but who cares, kind of. And you give it a little set of instructions. This is very generic. You can make them much more specific. The thing that is different is rather than defining this tool call twice, I say, okay, I'm going to annotate this agent with a decorated function. This function is going to become a tool that automatically gets attached to the agent. So whereas like last time I was passing this stuff in and defining it above, now I just define it one place and it automatically takes the description, the arguments off of here, and it repackages it in just the same way so that internally, if you could dig through now a layer that is formed around the model, you'd see basically the exact same thing. We don't have to specify the loop anymore because that's already built in. And then so you say, all right, well, dear agent, I'm going to pass in this user's request, and it's going to loop until it finishes looping, and then it's going to come back with a response. Guess what it's going to look like? Basically the same thing. Same query. It still has some concerns about like I'm not finding it, so it's going to run a few times, and it's going to have similar results. Nothing great, but blah blah blah. Maybe I'll write my next book on assistance because apparently there's nothing on Hacker News about it yet. All right, it's still easy, right? It just gotten easier. Now, since everyone has agreed on this notion of a tool loop, we don't even have to write the loop anymore. All right, now this is an interesting slide and an interesting demo because we're going to take the exact same example we just left with, and instead of defining a really narrow tool, let's search Hacker News, I'm going to give it three tools: the ability to read a file, the ability to write a file, and the ability to execute some shell command. And what you'll see is emergent from this behavior, emergent from just including the right tools, these models have been so trained around coding that that's all you need to write a really, really simplistic coding assistant. No bells and whistles for sure, but it actually does the trick. All right, so let's look at it. We start again in the main function. And just like before, we pass in the user message. One thing you should notice is the user just gets one message. That's something that we'll have to fix soon. Right now, there's no memory, but we pass in the user message, and the agent is defined just the way it was before. Nothing hanging off of it except for those three tools. Here they are, 1, 2, 3. No magic here. Read file. It takes a path, it gets the contents of that path and returns it, or returns an error of the string. Write a file. It takes a path, it takes the content to stick in that path, and then it does that and writes, we did a good job. Success or an error. Run a command. It takes a command, and then you can pass that into a subprocess. It executes it blindly. It takes the output and says, all right, I'm done. And prints the results of that command back into this list of messages that is being tracked now inside the agent. But the agent itself is just the same. You build the agent, attach some tools, and get the result out. So how could such a simple change do this? I'm going to give it a prompt. In this directory, create a CLI tool in Rust, which I don't know. I don't know how to program Rust. That generates the first n primes. Uh, Make a standard package, Rust package, build it, and tell me how to run it. All right. All right, so it's going to town. The first thing it does is it changes the directory, and it, because it's been trained to program anything, it knows how to initialize a Rust directory. It writes something that it thinks is going to be good. It's what's this? It's building the release. It's testing it to make sure it works. Thank you. And then it does exactly what I wanted it to do. In its final response, after it breaks through of this tool loop call, it says, here's the way you run it. Works. Isn't that beautiful? It's so simple. And let's look at what it actually built. It's inside this scratch space right here. And you have a full-fledged like Rust project. It's tiny, but you would be amazed how far you can go by just what we got right here. The only problem that we've got is that you get one request. It doesn't have any memory of the thing that we just told it. So that's the next thing to solve. But is it easy? I hope you see yes. Um, the only thing we've done is change the tools to be the correct tools for executing the work that we have at hand. We have not even given it instructions. So the next thing, perhaps I misspoke. We're not going to do the user conversation until the last step. But the next step is to make sure that our agent understands instructions. And guess what? This trivially follows again from the previous example. When we taught our agents how to read files on a file system, then trivially, guess what we can do now? We can leave little instruction notes. We can say, hey, by the way, Mr. Agent, before you get started, read this file. And so someone said, hey, let's call that agent skills and let's make it a new thing. But it's not anything special. It's the knowledge that we left a directory here full of useful content. And we're going to, in the system message, we're going to give you a hint about it. We're going to say, by the way, look over there if you need it. Here's, the summaries of all the things over there, but only look over there if you need it. And let's see how well this works. I've got to get a couple of assets over there. Let's do this with it. All right. The totality of this agent is 35 lines. This is a research agent. What makes it a research agent is we have told it where to look for skills. And we have also told it in the simple instructions, hey, by the way, buddy, you research things in Wikipedia. That's enough information for it. We'll look in these skills in a second, but notice that things are changing just a little bit. Whenever we created our agent this time, rather than letting tools hang off of it, even those tools have become so standardized. Read, write, shell, a few others, edit's really important actually, but there's not many. And some of the providers add just tons and tons of little tools. I don't know if you guys have ever used Pi. I'm a big fan. We'll talk about that in a second. But Pi basically is just four. It's read, write, edit, which we didn't talk about, and shell. But that's it. And it's my day-to-day coding agent. So because they become so standard, now with Pydantic, the way that they package it, this standard solution is by saying, okay, well, you can initialize a whole set of capabilities. This is a family of tools that go together. And it's also some other nice little things, like it will stick little piece of instructions into the hidden internal message about how to use this stuff. Shell, this makes sure that you can actually run shell commands. We could open the entirety of the internet to it by just uncommenting that line. We just don't happen to need it right now. And really, It already has everything it needs to read the skill files there, but we're going to go ahead and add the skills capability, which adds that little piece of instruction that says, hey, by the way, buddy, if you want to um, figure out how to do your job, then make sure you look in this skill directory and read the stuff in there. That's all there is to it, though. The agent's definition is like 3 lines longer. We've been a little bit more specific about the instructions. And now, whenever we give it a request, it will do the right thing. But there's one piece that we haven't delved into yet, and that's actually what it finds when it looks at these skills. You guys might know this, and perhaps I'm hitting some of you, I'm probably hitting way under like your already skill level, but um, skills are really pretty simple. You just say you put them in a directory that's named according to whatever your skill's name is. And then skills is just a markdown file that says, hey, you do this stuff. Um, it already knows that it's a researcher. And then when it reads this, it uh, it can see, all right, well, how do I research? Well, I've got apparently a specialized way of doing research. I'm going to create a folder for that question, and then I'm going to gather facts first, and then build a report. So their process is we talk about the facts file, we talk about the final report. You can do whatever you want to. The idea is you put your structure here. You put the set of steps here and you put it in English, which is, think about that for a second. That's kind of wild. We're programming in English. So let's let it be done. Why did the Roman Republic turn into the Roman Empire? It makes that first call there. Its first call, the first thing it decides to do is load the skill. So it's got an internal tool called load skill. That's the right one. When it loads it, what's the output? We just literally dump the whole contents of the file into the agent's messages. It just becomes the part of the prompt for next time. All right. Having read that file, it knows what to do, create a directory. It's going to start writing facts. It makes some requests to Wikipedia, so it's starting to actually look around stuff. And how does it make those requests? Just curl commands. So now it's got access to the totality of the internet just through curl, really. And finally, it creates this facts file using the edit file, and it writes a new file that is the summary of the port, and then it sticks it in the directory. So let's see. And it stick it in the same place. Here's my facts. It just, a list of things, and it also talks about where it got it from. It's kind of cool. It is searching all over the place to find the little pieces of the mystery. That's nice. And I don't know, but the models are pretty good at this point. If I wanted to learn about the Roman Empire, I suspect this would actually be a pretty well put together report. All right. Every step of the way, we have not introduced anything that is complicated or magical at all. But in the totality of the path that we've trod, um, some interesting things have kind of emerged. One thing that is, I think, is just almost miraculous, really, is the fact that a lot of the programming that you saw here, it's not it's not here in the Python. There's not much going on. The interesting stuff is actually happening in our skill definition. And in early 2023, the models were not really good enough at following instructions to make this feasible. But at this point, the models have gotten not perfect, but really good at following text instructions. So that effectively, you can put a set of steps inside a skills file like that. And the skills file, the programming language is basically English now. And agent skills are kind of our programs. And agents themselves which are almost uniformly, the way you set them up is like you just give it a set of tools and give it the model. These agents form a runtime that actually executes natural language, English code. How strange. But it opens up a lot of new possibilities. All right, our last of these demos, there's, as I mentioned, there's one critical thing that's missing. You could go back to that agent that just taught us everything about the Roman Empire and you say, all right, teach me more about Julius. And if you left out Julius who, it'd be like, I don't know. What are you talking about? Because there's no memory. And a key thing to make these agents really assistants is to have it where you can have a back and forth with them. But guess what? In introducing this, it gets no more complicated. All we do is yet another loop. So let's see what that looks like. Now this one does come in at a little bit longer. We're actually going to hit a few points in this one example right here. One thing is the user message loop. And then also, since this does actually come up a lot with the coding agents, we'll talk about hooks. And we'll show a really, 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 really stupid version of compaction. But hopefully it demystifies all of that. All right. Let's pack for the trip. We need an extra thing this time. And we'll get to it later, but there is going to be two agents really inside this example. One is a really dumb one that works just like our first slide. It takes an input, processes it, produces an output. And that input is going to be all the messages in our current conversation. And the output is just going to be a text file, a text output that just is a summary of it. I haven't given it very complicated instructions. If you go to coding agents and look at how they're doing it, it's very complicated. The way that, like, make sure you include file paths. You should do that. You should think about what the agent sees and write something that is going to make it work well. But when you get down to it, it's just going to be English. Summarize this conversation. All right. So we have an agent that we'll use in a moment. Our conversation now is stateful. It's got a message history. It's not just me saying something and we're done. It's me saying something, seeing the response, recalibrating the agent, and kind of having a dialogue going back and forth with the agent. And all you need for that is just a list, an empty list of messages. We'll add messages as we go. Summarizer will come along for the ride. All right. I'm going to skip over this section on the first run. Let's create our agent. Here again, same agent. We just say, here's our model. Let's see. We say that this time, whenever we interact with the model, it's going to be looking for this thing. So it will have access to that. We have trivially simple instructions. Obviously, if you wanted to be a particular type of agent, you make it instructions that are more useful. And capabilities, we actually have not given it access to file system or tools or shell commands or anything. So it's a very, 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 very constrained agent. But let's just see what it does anyways. All right. So there's our agent. Skip this for just a moment. And I said there's another loop. This is all there is. We instantiate a session, and then forever until I control C the program, we're going to let the user say what they want to say. We're going to give that to the agent and say, all right, just take it and run with it. And then whenever it comes back with the results, we're going to make sure that we add that back to the session. And we're going to print the results to the screen. All right, so let's watch what happens there, and then I'll get back to the thing that I skipped. All right, what was my prompt for this one? Oop. Oh, sure. Tell me a joke. That's why I can be so constrained with that. Why don't scientists trust atoms? Because they make up everything. Huh. Okay, so I'll say explain. I'll say why. And see, when I say it's explain, you can see that it is referring back to the thing that it just said. So we've got memory. The installing memory was as simple as just this while loop. Okay. Session memory. All right. We keep saying why because we're simulating my son. And at some point, something different happens. Summarizing earlier messages, conversation summary, and then it goes on. And then you keep saying why. Okay. So now we have a complete and total facsimile of a coding agent. Just it's very simple, but all the pieces are basically there. We have a session. It is as persistent as program, but it wouldn't be hard to just write it to a file instead of write it into memory. And we have compaction. So let's take a look at compaction and how that works. It ends up being pretty easy. A hook is the last thing that you commonly see in these coding agents. We have the coding agent and the agent in general is now just two loops. There's the inner loop that is calling the tool and go back to the model. And then there's an outer loop that is, as soon as we're finished with the tools, we ask the user, what's next, what's next, what's next. And that means that there's several cut points in our conversation. We have a start of a session and an end. We have right before we call the model, right after it comes back. We have right before we call a tool, right after it comes back, and a few others. And so at every one of those little cut points, that's a place where most of these frameworks allow you to have hooks, which are like little callbacks that allow you to create a function and say, whenever this happens, do this quick thing, check for me. And so the hooks are how compaction is implemented, and it's just pretty easy. In this case, we have given our agent hooks. And now since our agent knows what hooks are, we can hang off of these hooks different events. You know, when we're about to get a model request, then I want you to take the request context, and if the context has gotten a little bit too long, and now this would probably be in tokens rather than messages, but if it's too long, then I want you, if it's not too long, just return it and do nothing effectively. You're good. But if it has gotten beyond that, then we're going to summarize the first seven messages. We're going to tack that summary onto the previous messages, and we're going to repackage up the memory of this agent. So instead of 10 messages, it's now one big summary and 3 messages. And that's it. Now you have compaction. Make sense? All right. We have 20 minutes left. I think that's good.
John, do you want to like stop maybe for a breather in the case anyone has any questions?
I would like to breathe, yes.
Audience, does anyone have any questions? Does it feel easy yet? Or is the number of times John said easy overwhelming?
Yeah, I'm curious. Is this hidden like way below everybody, or is this like, oh, that's interesting how easy, where am I hidden? I guess.
You can speak if you'd like.
And what am I missing?
This is Betty Anna. I'll say that I kind of intuited this, but it's really nice to hear words that aren't in my head. And it's also really great how you're right, it's easy. And you're making sure that even your presentation is easy. So this is great for me.
Thank you, Betty Ann. Nice to see
Max
you.
agrees in the chat. He said exactly what Betty Ann said.
Good deal. Good deal. Yeah, well, let's put it to work. Now that a lot of you guys, and gals, it's you know this stuff. It's hopefully it feels obvious. Hopefully, it feels more obvious now than it did. It's like, oh, well, duh. In retrospect, it is as simple as that. There is no magic. The one thing that truly kind of is magic is at the very core, inside the user loop, inside the tool loop, we have this little amazing box that takes text and produces text that's kind of human-like. That's the magic thing. But emergent from that one little crystal is all this cool stuff that looks like this amazing agent, but it's just two while loops. That's it. And the correct set of tools. Once you get the correct set of tools and the correct instructions, which now you can stick into a file on disk, then you can do amazing things. And the instructions themselves are in English. All right. So can you take the thing that we just created in the last example and like replace Claude code with it? No, not quite. So even though I've been kind of poo-pooing the complexity, there are lots of things going on in Claude code. They're protecting you from some dangerous situations. There's permissions. There's a notion of like memory search, which ask me about that one later. I'm not on that boat yet. But there's a lot of interesting pieces in which do justify a rather giant code base. We all probably remember when the Claude code base got leaked, and there is stuff in there. There's garbage too. There's like a radio slash command. You can listen to radio. I don't know what that's about. But so if it's still intimidating, you think, man, cool, but this is still no good for me, then I want to show you one more thing. As all these puzzle pieces are becoming standardized, you don't have to wait for a frontier company to build a new harness for you because all these things are now Lego blocks. You just pop them together. And where I got on board with this ecosystem was with Pi. Pi is the core agent harness of OpenClaw and Hermes, I believe. And you can see the code. You can read the code. The code for the agent is actually, it looks about like the code I showed you. It's maybe about 5 times longer than what I showed you, but maybe only 5 times longer. Now, the harness around it that puts the slash commands and like all the hooks and all the extensibility, that's still a lot. How do you make the user interface look just right? That's a lot, but it's just traditional software, right? And since all these things are becoming so commonplace, you can start just making extensions really easily. Pi, go look up. I wish I had included a link here, but go look up the way that you can make extensions. Effectively, their extensions allow you to register all the tools that you want to. Um, you can register commands, so you got slash commands. They've got all of the hooks that you can imagine available, so you can basically pluck out compaction, replace it with your own compaction. You can do whatever you want to. And if that's not enough, I introduce Flute. I have not used this myself. Someone turned me onto this a few weeks ago, and I've been meaning to play with it, but it's got all the right smells. It is built on top of the Pi ecosystem. So these guys are buddies. But instead of making an extension system on something that is fundamentally still a coding agent, this is exposing the literal Lego blocks. You create an agent. You say, here's the model, here's a list of tools, here's all the skills. Sandbox is really a cool thing where you can say, this runs safely over here. Here's a set of instructions. It's just neat how these days you can have whatever you want. You can plug in the UI, you can do all sorts of stuff. So look at these guys and don't be afraid of building your own agent, like your own day-to-day coding agent even. All right. This leads us to the mind expanding part. The first part is like, let's show you how trivial the world actually is. And now let's show you that emergent from that simplicity is, the chaos. Now, since you know that agents are simple, effectively, how do we unharness them? How do we tear them away from the grueling task of software development that we subject them to every day? They can do so much more. How do we take them out of just the terminal because you can use them anywhere? Let's imagine some scenarios. The first scenario is instead of having the agent live in a terminal, if you're building an application, like take this one home with you, software developers. If at your company you're building software, then soon and probably now, the software is not just going to be built with agents, it's going to have AI stuff in it somehow. And everyone's like, well, how do you build that stuff? Like it's an emerging art at this point, but it's easy. It's super easy. Let's look at how you can take this idea of an agent and make it a component inside a traditional software application. I'll need 2 pieces of information for this. Yep. Yep, okay, these 2 things. Oops. Well, I certainly need a shell. All right. All right. This is really close, and Betty Ann, you saw like the long version of this. This is really close to something I built for a client recently. They had, I'll change the story. But they were looking over job applications and they had a bunch of reviewers that were comparing an applicant and a job description and trying to figure out if this is a good match and, let's move them on to the next step. Let's softly reject them and write some nice, email follow-up, or let's ask for more content from them. We're missing some information. And I built this. And the thing is, if I was to build that capability with AI, a year and a half ago, then I would have reached for like, I don't know, lane graph. I would have built some sort of bespoke on the rails process, some state machine for doing it. These days, this is how I think it's built. Okay. Um, guess what? It's the same thing. We define an agent. In this case, we're going to use a little bit smarter agent, Anthropic model. Um, we're going to give it capabilities, but not many. The capabilities that we gave this one is just the ability to read skills. If we wanted to be a really good research agent, then we would give it maybe like tools to search like a proprietary database. We might give it like web access. We could give it like file reading tools so they can look at files on this computer. But this case, all we need is give it skills that I'll show you in a moment. And the instructions are simple. You're going to review these candidates and, tell them if we're going to pass on them or if we're going to accept them, blah, blah, blah. It's really easy. All right. Now, where to use this agent? We create a function called review, which takes a job application and returns an AI application review. This is all it does. Given the application, it pulls out all the data and makes a pretty way of presenting it to the model as text, because the language of these things is text. And once we make it in a very legible format, we take that prompt, we pass it into the agent, and out comes a result, and we pass it back. Now, interestingly, from the perspective of the rest of the software, the whole rest of the software can be traditional software. This thing has a very traditional software looking signature. It takes something and returns something. And the magic is in this one line. If you recall, this doesn't have the user loop, so it's not going to follow up and ask us for a response. It only does the tool calling. And I want to draw your attention to one more little ingredient in this piece of magic. The output type is defined. We say it's an AI application review, which is right here. So this neat thing about Pydantic AI, it enforces the output of the model to follow what you said it should be. And if it breaks those rules, it'll try again and try again, which means it's pretty close to pretty deterministic in actually creating the correct output there. So let's go ahead and run it real quick. While it's running, we'll take a look at the skill itself. Um, the skill is basically a workflow. You need to do these 5 steps in order to justify your decision. When you have a decision, like here is how you print it back out, and here's just like basic guidelines. And whenever I do that, I'm passing in my good buddy Doug Turnbull, and I'm making him apply for a job that is just not in his wheelhouse. And correctly, the model loads the skill, reads how to do the process, recommends decline, and also provides us with the structured output. Now, the structured output has like the correspondence we send back, but it is the output that I told it to send back. So you can take an agent and you can use that is basically your own little Lego block in the code that you're building for your company, for your users. Now let's invert it. Let's do the complete opposite. Instead of forcing the agent into our application, I think the future holds a surprise for us here. I think a lot of times when we interact with applications, it is actually going to be us working with an assistant, an AI assistant integrated into the traditional feeling applications. And so imagine how this works out today. We have the notion of assistants, AI assistants inside websites. I helped build this one out when I was at GitHub. It's one of the internal Copilot products. You can ask it about issues and projects and stuff, and it'll tell you. And it's a good product, but there's a key problem. Even though it has tools and stuff that's useful to work, it does not know about whatever you are doing right now. You're having your day to day, you're working with your coding assistant probably, and it doesn't know what you're doing. So in order to make this thing work for you, you've got to copy and paste your context over there. It's a lot of work. Probably your security team does not like you copying massive amounts of text into a window in some website. So what needs to happen? Instead of this, I think it'd be great to make it where I can take my agent, I can bring my own agent into this application. So I'm working with my coding agent, which knows my code base, but also knows as soon as I show it GitHub, it's like, oh, okay, I've learned GitHub. I know its tools, MCP servers, whatever. And it's not just using MCP servers from GitHub. It is working on the same surface with me. When I say, find this information for me, it might very well just open up that page right there. When I say create an issue, I can see the text written out. When I highlight something in the text, it can see what I'm highlighting. And so my agent needs to have visibility into these applications, and we need to work together on the same artifacts, on the same surface. And it would be a much better experience. And think about, GitHub's the example right now. But think about any website you go to. Wouldn't it be cool if you could talk to your agent and your agent acts like a concierge, ushering you through the content, seeing when you click on something and being able to answer that because it sees it. So bring your own agent into the applications that you're working with. And the last one, to hopefully stretch us the most to think about what really potential lies ahead. This is a vision that will come true within 5 years. I'm building my own version of this, and so like, haha, it's an advertisement for Rook, my assistant that I'm building, but it's something that I think will happen no matter what by 5 years, and that's the idea of bringing our own agents with us on our phones, because we all got these things in our pockets, into real life with us. Our phones have access to lat and longe, of course, so it knows where we are. There's plenty of open data sets, free data sets, where you can figure out what building that's in, who owns the building. You can figure out what website that's associated with. You can also often find the exact store, if it's a store location. If it's a municipal park, you've got maps. And so imagine going out with your phone and seeing the world and having your assistant be able to usher you through that experience. Imagine going into a grocery store and being like, okay, well, help me get out of here. And as soon as you go to the grocery store, your assistant, because that's what it is, it's yours, it knows your shopping list. But as soon as you walk through that door, it knows the aisle layout, it knows the whatever's in stock, whatever's out of stock, and those discounts, and it can usher you through the store and get you out as fast as you can. And then you go home, and that context goes away, but you get the skills for home life. My thermostat, my Ring camera on my front door, my garage door, all this stuff, television, refrigerator, all these things. Internet of Things becomes the thing again. That's great. And I think what we'll see is eventually that this boundary that we're putting around our coding agents melts away and our agents become our assistants and follow us into the world. All right, so that's it. Agents, they are not magic. And as a matter of fact, all the magic has been basically encapsulated into little Lego blocks. You can build your own agent. It's not that hard these days. With the right set of instructions, tools, and data, your agents can do anything addressable by those tools. Your agents are simple to configure and build, but mostly their programming these days is done in natural language, in English. And so it's becoming easier to work with these things. Take your agents, embed it as a building block in the AI software of the future. Take your agents and use it as a different user experience, a concierge that walks you through the applications, websites, and locations of the world. All right, so how do you keep this information? Build it, do it yourself. Linked here, and Greg's gonna give away these things, but we have all the code examples from today. I talk about nitty-gritty details in my blog post. I've got plenty of videos and streams. You can even watch me building Rook. And there is Rook itself, in case you're interested. All right, that's it, and I desperately need some water.
That was awesome, John. I loved how like you walked through everything so cogently and how you built up from basically nothing to a lot. Um, we have a few more minutes. I think just to remind everyone, this lightning lesson was second in a spine of three before the course that we're doing, Hardcore Agentic Engineering, which starts August 3rd on Maven, begins. I think it's really important to understand mechanics of coding agents if you want to get better at agentic engineering, since a lot of getting better at agentic engineering is kind of developing your own harness, in addition to using those that exist. That said, any questions, we'll take them as they come.
Yeah,
Can I?
go on.
Oh, sorry.
Great, great.
You go, Ali.
Okay, thanks. So I was wondering about the difference between the agents you could build or the harness you could build or the system prompt and the quality of the agent in the end. Because I mean, my feeling is that Cloud code for me it's better, or my feeling it's better than Codex because of this system prompt somehow. Like I don't know, like there's some internal reasoning or like this internal terms. I don't mean how many terms that does, but my feeling is that the codex is like a more of an executor, right? Like now it's better, it's a bit better. That does a lot of internal turns, but so it does the job, but it just does it, right? But Cloud seems now the system prompt. I don't know what kind of system prompt there is inside, but it seems to be a bit more convoluted in that. So the question, to be concrete, is how can you get something like that just by writing instructions? Which goes to a part. The second part of the question is that I tried to do this as well, like by editing agents MD or Claude MD, but I don't get the same result. Specifically, if there are some specific instructions with time, the agent does not comply to these instructions. But I imagine with Claude Code, it does not happen, right? Like because if this would happen, we'd have a catastrophe probably. I mean, they probably have something internally, I don't know how, that it never defies some guardrails, right? Where is this in this loop? Because it seems a very simple loop, right? Like as you just explained.
So Claude Code has a benefit that I think is slowly evaporating. But the benefit is that they get to train the models to work as best as possible to their own instructions. And so they're super finely tuned to their own system messages. But the models are getting much better. In 2024, when I was working on that little Copilot agent, you'd say, please do this, and it would do it for about 3 turns. And not like 3 user turns, 3 like code calling, tool calling turns, and then it'd wander off to do something else. But the agents have gotten so good at reading the text and following it that like English is like legitimately becoming, uh, it's still stochastic, but it's really becoming a programming language. Um, but I think it's evaporating as they get so much better. Also, part of the secret sauce a little bit is in hooks. Like when we say slash loop, what's happening is really when the agent returns, the hook is going to say, okay, the agent's finished, and then it's going to like look at it and say, are you really, really, really finished? And if it's not, it's going to kick it back off so that you don't have to. And that gives you the feeling that it's going to keep going until it finishes. It's cheating a little bit, but it's still not that hard.
Hey, John, just to kind of add a little bit more color to that answer, in the chat, I pasted a repo where someone's documented all of the Claude Code System prompts. I think if you click on it just because you have your screen shared, it might be useful to see because it's really interesting, like how many system prompts there actually are. So click on system prompts there, top folder.
Yeah.
And this is probably one of the reasons why, if you were to compare and contrast, the source code of Codex or Pi or what John showed, I mean, of course, there's a lot of system prompts for a lot of like extraneous pieces of capability in something like Claude Code, but there's a lot of instruction sets, which is probably why if you try to roll your own, I mean, just the breadth of what you might have to consider, assuming you're not trying to, develop like system prompts for extraneous functionality, like I don't know, some of the stuff that like Claude Code does that you wouldn't need it to do. Like they have a notion of, like like I think they call them beats or reminders, basically like the orchestrated cron jobs. Like you might not need that in yours, right? But they have something kind of for everything.
But sorry, is this the system prompts from Cloud Code, the actual ones? Because there's this one that got leaked, I think, was like the end of the beginning of the year, or is it like open source? I'm not sure.
So,
I don't know.
so Claude Code, the harness is not open source. There was like an NPX publishing snafu earlier in the year where the source code did get leaked, but people regularly reverse engineer system prompts, and so this is one example.
Hmm.
You could see like all the system prompts, for example, in like either Pi or Codex, because those harnesses are actually truly open source, if that helps. Like almost every model and agent, every one of the system prompts gets leaked and they normally get hosted on GitHub or reverse engineered.
Thanks.
I think there was another question. I don't know who was asking it before Ali asked.
Yeah, it's
Oh,
Max.
Matt.
Thanks so much, John. That was super interesting. And just to follow up on what Betty Ann said earlier, I think I was like aware of all the bits and pieces, but the really useful thing is to see how they're like hooked together and how they interact with each other, like how information flows from one to the other. And so your code examples have been really helpful in clarifying that.
Great.
I'm curious about um, memory, and you've touched on it a few times. You also said like I don't know how much you can or can't say about it, but I'm just curious because I find myself effectively like rewriting the same things in different ways in either like skills or like additional like context files or whatever.
Hmm.
Also, like I'm trying out different harnesses at different times, so I do find that repetition as well. But I'm trying to build up something that is effectively an extension of my workflow.
Hmm. Hmm.
Um, and but it's much harder work to um like make it sufficiently like comprehensive and make it stick than I thought it would be. And I'm kind of I'm not really sure what my question is, but I'm wondering. So I mean, I've seen if people build like their whole like memory systems and maybe databases and try and like retrieve only the relevant parts for a query and then like reintroduce it into a new like build up the prompt every single time. And like, what's your feeling on how well how to build something like that up for like a custom use case, like a personal use case that you've described? And
Mhm.
what's the most effective way of sort of like providing that additional contextual knowledge for everyday tasks?
I have opinions and guesses, but nothing definitive. My opinions is this is an opinion that I still need to do my own due diligence and prove myself right. So take it with a grain of salt. But I don't like I come from a search background, right? I wrote a book on search, but I don't like the search-based memory because they don't work like humans do. When you do something at work, you got a new project to build a front end, and then it's over, and the boss is like, "Why didn't you use the design system?" Blah blah blah. I'm so upset. You don't surface those memories based on the exact word matches or even the meaning matches. Like next time we're talking about like button offsets, you're not like, oh, okay, I've got to use the design thing. Well, a human is like, I've got to use the design thing. But an agent's like button offsets, how does it know that this is time to make a query about button offsets and see if problems have arisen about button offsets in the past? And how does it know, like if those words are not going to match anything terribly meaningful? I got just a lot of complaints about that philosophy. Someone should prove me wrong. I really hope someone does. The thing that my intuition is that until the models can update their weights while they're talking to us, the the best shot we got is something close to skills, where you're probably doing something like it already, where it's like I've got a task. Here's what I do. When I'm working on a task, I won't do it. I'll have my agent do it for me. And then at like little cut points, I'll be like, ooh, that was a good lesson learned. Let's put it in like just like this prototypical version of a skill and let's build it and shape it. And next time we do that task, let's go back there and, break off the edges and do stuff. I'm still working on it. It's definitely more art than science. As far as just like interests, I think all these ideas about tasks tend to be a network of skills that are interrelated. So like every time I build a skill, I've noticed that this skill over here really needs a little bit of information like from this reference file. And so I'm thinking about shoving everything into an Obsidian directory full of documents and having that be like a mega skill, but I haven't played with that enough yet.
Yeah, thanks. That makes a lot of sense. And actually, I mean, I've been using Obsidian sort of like a second brain style for a while, and it works quite well actually in terms of just providing that. But it's interesting. I mean, I'm curious also. Maybe you and perhaps Greg also have opinions on how how well do you see the models um, deal with just as you say, like plain English input versus like the structured and enforced guardrail type like tool or extension in Pi or something like which one do you prefer in your own workflows? I mean, do you see the models basically do things pretty well, or are you more on the sort of like I want to control everything, I want to be really clear about what they're allowed and not allowed to do within a certain skill or something? I'm curious. I mean, there's probably no right or wrong, but I'm wondering what you yeah how you approach that.
For me, it's been kind of a spectrum, a continuum where that has been moving in time. In 2024, you don't trust a darn thing that these things do because you say, please make the structure and the JSON itself won't be correct. It'll like double escape quotes and it'll just be wrong. And so we had lane graph and you've built very controlling structures for like how you think through these things. And they worked. They were important because they had like, retries and stuff. Um, and then these days the models have gotten good enough where it's really, really, really common that they return exactly what you would expect them to do. And you can even coerce them. Like one way to trick a model, an agent, into making the final output be what you want is to give it a tool called final output that has a schema that's exactly what you want. And the models are super trained to put the arguments into these functions well. So when you just get that function call, your hook's like, okay, kill the model, we're done with it. But you can also there's also always a risk that it'll fail. Pydantic's cool because like you can just say what's the output, and it'll do a retry, and you can say the number of retries, and so it'll do the right thing. It can be a normal tool calling agent into the last step, and then it'll make sure it makes the right output for you. But in general, like the future is ripping out complexity from the agents. The agents are going to be just configuration, a lot of it, and then the correct English skills file, which is blows my mind, but I just think that's the way we're going.
So I have one thing to add, and then I think we should probably wrap up in like 3 or 4 minutes here. But this has been super interesting. I love these types of questions and engagement. So Max, on your sort of question, John was talking about like the future being like package skills as one way of kind of preserving memory, if you will, of like what you are attempting to do without necessarily relying on like a in-depth like retrieval process or creating your shared brain, although a lot of people are fascinated by that. This is sort of a shameless plug, but as a co-founder of SpecStory, I'd be remiss to say that if you want to auto-generate skills from your sort of latent uh, corpus of coding sessions that have a lot of probably repeated patterns, this is super meta, but we built a skill that creates skills from your exhaust as you use your different coding agents. The other reason why it's relevant to bring up, I pasted the link into chat here, is because it also has an opinion about what you asked, like the mix or the spectrum between like deterministic sort of guardrails and non-deterministic LLM calls. One thing that I think a lot of people are sleeping on, and probably because there's just not a lot of patterns of this in the wild yet, are the fact that skills can be more than just markdown files. They can be invoked with the front matter of a markdown file and have the instructions in English language, but you can also incorporate like programs, executables alongside of skills and package them together. That's actually how this lore skill was created. And I think that gives you the sort of best of both worlds, because if you actually go and invoke this on your own machine, you'll see that there's a lot of like sugar in terms of, how you're prompted to interact with it, how it returns messages and formats results, and like a whole control flow underneath the hood, even though the interface that you use is Claude Code or Codex or insert agent here. And another good example of a skill that's you may or may not have heard of before that uses a very similar approach is the last 30 days. It's a really great skill. Let me pull it up for everyone that allows you to basically get trending information from all sorts of social media and Reddit, whatnot. And it also has, it's by Matt Van Horn. Um, it also has sort of like a deterministic sort of parsing engine with a very large sort of skill prompt around it that makes it sort of a pleasure to work with. So it's my 2 cents.
Well, thanks a lot. Super interesting.
Yeah.
Thanks,
Any
Matt.
last question? We'll take one more and then we're gonna wrap.
If nobody has any question, I would add one more, but I will wait in case anybody wants because I already
Okay.
asked. Okay, so let's just make it quick. So I'm building like trying to make two agents work together. But like two on two different servers, but whatever. But I was wondering about because I've read before that if you use the two different models, the output would be different than you have one model in two agents, right? So the question was if I need to be more careful with the system prompts with the harness with the guardrails, I'm really using two different models. Do they somehow sense each other? Or really have to just try it out and see what happens? Is there some, I don't know, experience from you coupling different agents with different models or the same model or not?
Uh, Not coupling different agents with the same model. Um, no, not a lot of experience like doing that because that would require like a more, like Switzerland harness. I like Pi or like Copilot or Cursor, for example. I haven't done that much myself, to be honest. Like to
Yeah,
just observe the differences in the harnesses. Normally, for me, it's like, comparing kind of like the intrinsic model plus harness of Claude Code and or Codex most of the time, personally.
as far as like I don't know exactly what you're doing with making the two agents talk to each other, but I have heard this. If you take one of the agents and pull it open, and instead of having one model in it, just have two and randomly choose back and forth, like just the next time there's a model request, just flip a coin. I had a friend that co-authored one of these books with called that annealing, alloying. And basically, he found out that if you took two different families of models, that the resulting output, they were doing like penetration testing. It was a lot smarter because it take a little bit of the like part of the thoughts was coming from Claude high level, and part of the thoughts was coming from GPT high level, and they just like they filled in each other's blanks and came out with something that was significantly better. The results went away when you chose two different powerful models from the same family because they had this same training. But I thought it was kind of interesting that alloying models together makes them significantly stronger. How about that?
Yeah,
Cool.
you just draw the conclusion from this paper where they did this emergence work. I don't know if you guys picked it, but it was like an extreme case. They did like let agents run for weeks, I think, from different models, and was that the output was that the taking different models it became worse than taking the same model. But this was a very long-term experiment,
Oh,
so I
interesting.
was wondering if the like short-time experiments would have also the same misalignment they said, right? But yeah,
Yeah.
whatever. Thanks. It was super helpful.
Thanks.
Well, great. Well, thanks everyone. Tune in next Monday. We have another lightning lesson scheduled. I just dropped the link below and hope to see you there.
Thank you so much. This was awesome.
Alrighty.
Thanks.
Bye-bye, everyone.
Bye.
Thanks, John.